Hi guys, if you have questions, email me or write a comment.
Let's talk about some special right triangles that we have. We have 30, 60, 90 degrees right triangle. So we have such a triangle here. Right triangle. Let's say this is the 30 degree, this is the 60 degree, and as we said before, each angle has a special ratio. So 30, as I've explained in the other video, the sine of 30 will always be half, so the opposite side is 1, and the hypotenuse 2, it's always half the hypotenuse, and the third side will be radical 3. This is always fixed, so actually sine 30 will be 1 over 2, which is the opposite side over the hypotenuse. Cosine 30 will be the adjacent side of 30 over the hypotenuse, which is in this case radical 3 over 2, and tan 30 will be equal to opposite over adjacent, which is radical 3. So it's 1 over radical 3. Now, the interesting thing here, it's easy to memorize the rest. If I'm thinking of sine 60, sine 60 is the opposite side of 60, which is radical 3 over the hypotenuse, radical 3 over 2. Radical 3 over 2 is already cosine 30, so actually this is the same as sine 60. What about cosine 60? Cosine 60 will be the adjacent side of 60 over the hypotenuse, which is 1 over 2. So actually that's the same as sine 30. So cosine 60 is the same as sine 30. About the tan 60 is radical 3 over 2, the opposite over the adjacent. So it's the reciprocal of this one. So tan 60 will be equal to radical 3 over 1, which is radical 3 only. So it's not hard to remember these. You can remember the triangle, or you can remember that sine 30 is half, and from Pythagorean you can get radical 3. Since you know sine 30 is half, you'll immediately know that it's the same as cosine 60, and you will know that the remaining will be radical 3 over 2 for cosine 30, which will give you sine 60. About the tan, how am I going to remember this? Well, tan is also easy. Tan is opposite over adjacent, and we are using opposite for the sine here, and we're using the adjacent for the cosine, right? Radical 3. So tan is opposite over adjacent, so it's just like sine over cosine. If you divide half over radical 3 over 2, you will get 1 over radical 3 only after simplifying. So actually this could be something useful. You can remember that tan any angle can always be its sine over its cosine, as simple as that. So if you know the sine and cosine, you will be able to get the rest: tan, cotan, secant, cosecant, and cotan also. Here we know sine 30, as we said, so sine 30 can give you the cosecant, which is 2 over 1. Cosine 30 is radical 3 over 2, so secant 30 will be 2 over radical 3, and so on. We have explained this in a previous video. This is the first special right triangle, the 30, 60, 90. Another special right triangle is actually the isosceles right triangle, the 45, 45, 90 degree right triangle. So if you draw a triangle here, an isosceles right triangle, I'll try my best to make it isosceles. So if I'm talking about an isosceles right triangle, let's try to fix it if we can. Okay, so let's say we have a right angle here, we have 45 degrees here, 45 degrees here since it's isosceles, so these sides are the same. Let's do it in a simple way. Since they are the same, let's say 1 1, for example. By Pythagorean theorem, you will get that this will always be radical 2. If you have 3 3, then this will be 3 radical 2. So the simplest form will be 1 1 radical 2, which means sine 45 is the same as cosine 45, since the adjacent and the opposite are the same, and both will give you 1 over radical 2, 1 over radical 2. Or if you simplify, if you rationalize, that will be radical 2 over 2. Any form you want to remember, that's up to you, as long as you rationalize the denominator. What about tan 45? That's a very special angle. Tan 45 is opposite over adjacent, which is 1 over 1, so it's always 1. These actually are the two special right triangles that you need to remember their ratios. Sine cosine 45 is 1 over radical 2. Sine 30 is half. Cosine 30 radical 3 over 2. Cosine 60 is half. Sine 60 is radical 3 over 2. It's better to memorize these because that will make your life easier when you are trying to solve trigonometric equations. Okay, my next point actually will be something more interesting. If I want to draw one of these angles in a standard position, let's say I want to draw the 30-degree angle, for example, in a standard position. So let's say this is 30-degree angle. Where is the triangle? Where is the right triangle? Well, here is the opposite, and here is the right angle. So we have the opposite side. Sine 30 is 1 over 2, so 1 over 2. We have the adjacent side, which is radical 3. So if I'm talking about 30 in a standard position, the initial and the terminal side, then this is what I'm gonna get. Okay, let me just write this down. Sine 30 is equal to 1 over 2, which is the opposite side over the hypotenuse. Okay, I need you to look at this point now. If I need to know the coordinate of this point, what's the coordinate of this point? Coordinate of a point means x and y. So what's the x value here? X value means this distance. So how much is this distance? It's radical 3. Where's the y value? The y value means the height, right? This here is the same as this length here. So this is the y value. So it's 1. So when I'm talking about sine 30, this means I'm talking about the y value over the hypotenuse. So it's y over the hypotenuse. When I'm talking about the cosine, where is cosine 30? It's the adjacent radical 3 over the hypotenuse over 2. And the adjacent is actually represented by the x value. So it will be x over the hypotenuse. What about tan? Tan 30. Tan is opposite over adjacent. So it's 1 over radical 3. Opposite, which means y, over adjacent, which means x. So in general, if I'm talking about an angle in standard position, I can use the point x and y coordinate to find the trigonometric ratios. Okay, that will be more interesting now. Look at this. If I want to draw a circle here, then where is the hypotenuse? Where is the radius of this circle? This will be the radius of the circle, which means this is also a radius of the circle, so this will also be 2. Here it's 2, here 2. All of these, here, all of it will be 2. So I'm talking about a circle here that will be 2. Why am I saying this? I just want to put small example here. We start from 0 until we reach here, that's 90 degrees. That's obvious. What's the point here if this is 2 on the y? It will be 0 and 2. So if I want to talk about sine 90, cosine 90, and tan 90, the 0 represents the x, 2 represents the y. So sine 90 degrees will be, where is the sine? The sine is y over hypotenuse. Where is the y? The y is 2 over the hypotenuse, which is 2 again. So that will be 2 over 2, which is equal to 1. So sine 90 is equal to 1. What about cosine 90? Cosine 90 is equal to x over h. So it should be the x coordinate, which is 0, over the y coordinate, which is 2. So 0 over 2, that will give me 0. So sine 90 will be 1, cosine 90 will be 0. I'm going to depend on this. I hope that you understood from where did I get that, and that you understood these ratios. I'm going to depend on them. We can use simpler circle instead of using radical 2, 1, and 2. We can use a unit circle where the radius is 1. So let's try to do that in general here. I want to draw a unit circle where the radius is 1. Let's say that we have a circle here where the radius is 1. Okay, if the radius is 1, this means that this point will be 1 and 0, 1 for x, 0 for y. This point here will be 0 and 1. This point will be negative 1, 0. This point will be 0, negative 1. And as I mentioned up, sine y over h. So sine depends on the y coordinate. The cosine depends on the x coordinate. So if I want to talk about 0 degrees, then cosine 0 will be the x coordinate and sine 0 will be the y coordinate. So the x will be cosine, the y will be sine. So cosine 0 is 1, sine 0 is 0. Cosine 90 degrees is 0, sine 90 degrees is 1. Here the angle is 180, so cosine 180 is negative 1, sine 180 is 0. The angle here is 270. So cosine 270 is 0, sine 270 is negative 1, and so on. If you continue the circle, you will get to 360, and of course the coterminals. So 0 and 360, their cosine is 1, their sine is 0. So in general, in the unit circle, the cosine will be the x coordinate and the sine will be the y coordinate. So this is the easy way to remember sine and cosine for the basic angles 0, 90, 180, 270, and 360. I hope that this was useful and you can remember this easily.
Remember to like, share, and subscribe, and write your questions via email or comments.